Next one is graphics processing units. It's a technology evaluated to deliver unique benefits in that world of computing. It's graphical processing. Graphical processing is having units. It's having the content operations, machine learning, and so more. What does you in GPU do? Yes, general graphic processing units GPUs as one of the several important types of studies computing topologies, both the general and that is personal and the business computing, designed to the parallel processing CPUs of wide range of applications to indicate the graphics and video recording, although its capabilities and is having the more original and designed to the access of rendering of 3D graphics. Once they become more than flexible on a program, so expert conduct the process programmer to create and reversing the effects. The GPU and CPU's work techniques. The GPU is similar to complete the close things, and the CPU's process confused performance of the through the vertical generator and the clock speed, and it's additional designed to accelerate the computer graphics and it's sharp to the systems. So CPUs and graphics carried what is different. So GPUs graphic card and the video card change and it starts to sustainable decisions between these terms. So GPUs is to this GPUs and it's correcting the signals and transfer the data. So integrated graphics process and direct graphics processing unit. The GPUs gaming and then contest and then machine learning. It's having the it's a data center. It's having Intel supports to amazing to experience. Likewise, it's processing. So these are all the instruction level parallelism in a graphical units process, and it's having the graphics units and its differences. Normal CPU and the GPU. It's a graphical adapter, and we can use the graphical current to modify it. So these are all the instruction level parallelisms. Next one is instruction level parallelism concepts and challenges. So instruction level parallelism. Instruction level parallelism. Instruction level parallelism is a loop ready and add, scale up and store and decrement branch one is then it's having the following codes are on the memory and the function F1, F2, everything. So when the dependencies, control dependencies, data dependencies, and the link process, everything is held in this one. So the instruction level parallelism concepts and static and the dynamic software dependency in static, dynamic and hardware dependencies. So using for loops and graphics on the CPUs as a cycle per instruction will be executed. Then pipelining cycle per instruction include ideal pipelining CPI plus structural stalls, the data hazards and control hazards. So here it's taking the The techniques and its reference of instruction level parallelism, so various of data types of hazards, data dependencies, and then control hazards and structural hazards. And the control will flow that the P1 is a variable 1, P2 is a variable 1, it's having to allocate the data and transfer the data. So these instructions are transferred to that particular thing. So these are all the instruction to the P of S1 and the P of S2. And then the P of S1 is to control dependencies of both the boxes, and is having the control dependency of the branch, and it can't be the most reduced in the branch of to that corrections of higher continuous of this following. Next one is direct memory access, DMA is a method to allow the input output devices to send and receive data directly to or from the memory by passing the CPU speed of the memory operation. The process to manage the chip known as the DMA controller. So defined to as the memory is used to send the data and the data security from the mother's board without involving the microprocessor. In order to configure DMA channels is number 0123 and its industry depends upon ISA as experience is having channel 1 2 3 4 5 6 7, and it's having also the address, memory address, numbers, request numbers, and the DMA in certain locations. So it's having is processing other tasks to data transfers to perform, and the data transfer is to initiate the CPUs, and data clock can be transferred from the memory. And the bus mode is having the system is released after one is completed. The cycle stealing mode is during the transition of the day, and its cycles is having the performance of the others to complete and receive the interrupt signals. However, the DMA controller is to make the causes the cache memories and the stores the RAM access of DMA controller and correct the cache data if the CPU is used externally. And the solution to include closing the cache lines before starting its transfer, performing a cache individual by incoming the DMA. These are the cache memories, so citing the signals from the direct memory access nearby the cache memory. So data transfers from source to destinations and transfer the data itself. These are the data support input output direct memory access, which is used to transfer data from source to destinations from a certain points of a thing.